Checking whether a robotic motion plan contains any collisions is a fundamental subroutine for certifying the safety of any robot. Called dynamic collision checking, this operation happens hundreds to thousands of times in randomized motion planners, and so needs to be very time efficient. Due to both its ease of implementation and its high speed, many practitioners resort to the simple strategy of finally discretizing time and checking whether the motion plan is in collision at any of these large number of fixed time points. This strategy has a fundamental trade-off. Discretize time too finely, and your collision checks take very long. Discretize time too coarsely, and you may miss collisions. In general, it is hard, if not impossible, to verify whether one has sampled enough to certify that no collisions occur. In this work, we propose a new method for dynamic collision checking. Based on sums of squares programming, our method provides a rigorous certificate that no collisions occur in the motion plan. Moreover, it is both sensitive enough to discriminate the safety of two motion plans that differ only by millimeters, and is fast enough to certify RRT motion plans for bimanual manipulator in a second. Our method is based on the simple observation that two convex objects don't collide if and only if there exists a hyperplane separating the two. Finding this hyperplane is a simple convex optimization program. However, as the robot moves over the course of a trajectory, the hyperplane may need to move to continue certifying non-collision. Therefore, we need to find a parametric family of hyperplanes that move as the robot moves over the course of the trajectory. Finding such a hyperplane for every pair of objects which can collide in the scene serves as a certificate of non-collision over the trajectory. These hyperplanes can be found using a convex optimization technique known as sums of squares programming, provided that the motion plan is given in an algebraic reparametrization of the configuration space. This idea has been explored in prior work to certify that entire sets of robot configurations are collision-free. Our key insight is that by restricting ourselves to arbitrary piecewise polynomial trajectories, we are able to find certificates of non-collisions in seconds rather than hours. The result of our method is a formal proof in the form of hyperplanes which can be visualized as the robot moves. A unique hyperplane is found for each polynomial segment of the trajectory and for each pair of geometries which can collide in the environment. Here, we visualize only the hyperplane between the gripper and the top shelf for clarity. Though not fast enough to completely replace faster sampling-based collision checkers, the method is more than fast enough to serve as a final safety check, certifying the safety of this cubic spline motion plan in a handful of seconds, and certifying the safety of bimanual RRT motion plan in just over 1 second.